Okay, stats kids, I am gone today, but we are going to go through a little bit of the section 9.1 notes as far as we can get. I do not have a fancy calculator with me, so I'm going to fill out some of this formula and then do most of the hypothesis testing. I'll kind of show you how to do that. And then I'll stop a little bit short and we'll finish the rest of that tomorrow. But I will give you something to work on for homework here. So in all of chapter 9, so I'm on the notes page. In all of chapter 9, what we're doing is we are, instead of for hypothesis testing what we did in chapter 8, we would say P is equal to 50% when P is greater than 50% or something like that. And we would do our hypothesis testing. It's a little bit different in chapter 9 because what we're doing instead of that is we are testing two proportions against each other. So I have two different sets of data, and I'm saying, okay, let's say proportion of this data in one set is equal to the proportion of the data in the other set. And then the proportion of one is maybe greater than the proportion in two. So let's say I'm talking about test scores of students in one class period versus another class period, okay? And so let's say I'm talking about the proportion of people that pass and the proportion of people that pass. So passing in one class and passing in another class, let's say the percentage of people that pass is the same. But then I'm going to compare that down below and I'm going to say, okay, let's say instead that my first period class has a higher pass rate greater than the second period class. Okay, so now instead of comparing it to a number like we did in chapter 8, we're comparing two sets to each other. And it's exactly the same hypothesis testing. The only difference is your test value that you calculate. Normally, over here, we would have done z equals, it was p hat minus p over the square root of pq over n. This formula now is a little bit more involved in that it's got a lot of stuff going on here. So but otherwise the hypothesis testing is pretty well the same, okay? So I'm going to hold off on this formula real quick, and I'm going to explain to you how some of this works down here. Let's fill our bell curve out, okay? So proportions of cars with rear license plates only. Did you know that in some states, it's not required that you have a front license plate and a rear license plate? Sometimes you only have to have rear license plates. I don't know, whatever. So evidently Connecticut and New York are places that you only are required to have a rear license plate. And so they're talking about the proportion of cars that only have rear license plates. Some people do elect to have a front and a rear, even if you only need a rear license plate. So Connecticut, there are 239 out of 2,000 cars that have rear license plates only, which is about 11.7%. New York is way smaller than that. Only 9 out of 550 have rear license plates only, okay? So that is about 1.6%. And what we're doing is we're saying, are those proportions equal to each other, okay? Look at the two things that we're comparing. We are comparing 11.7% and 1.6%, okay? So we are going to say that P1 is equal to P2. Connecticut is equal to New York, right? Connecticut is going to be my P1. New York is going to be my P2, okay? I'm saying that those are the same. Now, these don't look the same. 11% does not look like 1% to me. So I'm going to guess that we are going to say that they are not equal to, right? I'm going to guess that we're going to say that this is true, okay? So it says use a 0.05 significance level, so fish value is 0.05, and the p-value method, we're going to do p-value and critical value method, to test the claim that Connecticut and New York have the same proportion. So we are claiming that those numbers are the same, even though they don't look the same, because these two percentages don't even look close. So that's what we're doing. And we're setting up everything exactly the same. Since we have equal to and not equal to, we have a left and a right tail. 2.5% is going to go in each one because we have to split it, which means that we have 95% in the middle, okay? So if we're doing p-value method, here's how p-value method works. Okay, p-value method works like this. 0%, my cutoff is 2.5%. Then I've got a 97.5%, and then I've got 100% over here, okay? If I'm doing critical value method, I'm doing 95% for critical value method. 95%. And 95%, I've got to think, is 1.96, I believe. So I've got negative 1.96, positive 1.96, and that's how that works, okay? So we're going to do all that stuff. Then the next step in this process is to find the test value, which is all this mumbo jumbo here, okay? So let's boil this down real quick. We know, let me get rid of some of this stuff, okay? We know that p hat 1 is going to be this 0.117, okay? So I'm going to start with z equals p hat 1 right here is 0.117 minus p hat 2 is 0.016. Okay, now they say that P1 minus P2, this part right here is what I'm going to have to subtract next, okay? And this is kind of like this chunk in your formula, P1 minus P2. Okay, they say that P1 minus P2 will be 0, all right? This part of your formula will always end up being 0, and I'll show you why here in just a second. It almost seems silly that we even write that part of the formula, P1 minus P2, but we have to have it there because that's what makes the formula make sense. But it's always going to be 0, and the reason why is this, okay? If our hypothesis is that P1 is equal to P2, we're hypothesizing that P1 is equal to P2, okay? What's going to happen if these two things are equal and I subtract them, right? What happens if I take P1 minus P2 and they're equal to each other? Well, that's just going to come out to be 0. So that's why in the formula you end up with 0 here. Okay, so minus 0. Then I have the square root of, we have to find P bar. Oh, this is disgusting. Okay, P bar, they break this down for us and they say that P1 is 239 over 2049 and 9 over 550. Okay, that means this is like x1, this is x2, this is n1, and this is n2. Okay, so if I add my x's together, I get 239 plus 9 over 2049 plus 550. Okay, 239 plus 9 is 248 over, this will be 2599. Okay, so P bar will be whatever 248 divided by 2459 is. Bloop, 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 bloop. 248. I do have a dumb calculator. Divided by 2599. Okay, and so for P bar, I get 0.095, let's say. Okay, that means that Q bar will be the opposite of that. So if I subtract that from 1, I get 0.905, let's say. Okay, that's what that will come out to be. So I'm going to put those in here in place of this. Okay, so 0.095 times 0.905 over my N1 right there, which is 2049, plus, see, this is why I really, really wanted you guys to figure out how to write these equations out. 0.095 times 0.905 divided by N2, which was 550. 550, okay? All right, and I have a dumb calculator, so that's all the further I'm going to be able to do, but this is your z value. We'll finish this example tomorrow, and we're really close to our example. All we have to do is for z, I need to figure out where on my bell curves he's going to live and which conclusion I'm going to go with. Do we think that those two are equal to each other, or do we think they're not equal to each other? I think that we're going to end up circling this one because I don't think there's any way that 11% is equal to 1%, but we'll see according to what they say, okay? So if you want to go ahead and figure out what this value is, go for it and come up with a conclusion, but we will pick up there tomorrow. What I want you to do for homework is to, is it too much to say do the rest of these? 5, 6, 7? You guys got lots of time in class. 5, 6, 7, 8, 9, 10, 11, 12. Do the best you can with those. Like 11 and 12 aren't really short. Like there's only the 4 numbers in your formula, so they should be kind of short. Okay, so why don't you work on doing those for tomorrow? Try to get the rest of that sheet done. This is just your practice sheet. Like, do you know how to type this into your calculator without getting an error? Do you know how to plug those in correctly? So work on doing some of those. They give you exactly what everything is. You just have to plug it in and get a result. Okay. So work on doing those, and then starting tomorrow we'll start doing some hypothesis testing. Okay, and do some of these on the homework number 2. Okay. So work on those for the rest of the time in class, and we will reconvene tomorrow, Friday.